Hello and welcome to Maths with Jacob. This lesson will focus on integrating the trig functions. A special puzzle to warm up the brain cells is on the next slide. The answer will be given at the end. Enjoy. What is the meaning of the following? Good luck with it and see how you go. As I have mentioned in a previous video, integration is the reverse process of differentiation. So the integral of sine x dx is minus cos x plus c, and the reason we have a constant here, that is an indefinite integral, there are no limits. The integral of cos x dx is sine x plus c, and the integral of sec squared x dx is tan x plus c. These three here are exactly the same as those three, except we have a constant in each case, so you just have to allow for the constant. And that's what I've done out here. And don't forget the negative sign here, because anytime we go from, for example, if you differentiate cos, you get sine. But we have to have the minus here because we have plus on that side. So don't forget, always allow for the constant when it occurs. Now, here are some examples to illustrate that. So the integral of cos 8x dx is 1 on 8 sine 8x. We quickly check that. If you differentiate from that side to that side, sine 8x. Now if you differentiate 8x, that gives you 8. 8 times 1 on 8 is 1. So there's your 1. And when you differentiate sine 8x, that gives you cos 8x. So always allow for the constant. In a similar fashion here, the integral of the left-hand side is that answer, allowing for the constant. The integral of the left-hand side here, the integral of cos x over 5 dx is 5 sine x over 5 plus c, allowing for the constant 1 over 5. That's why we have 5 here. And that's a similar manner here. Always allow for the constant, because when you differentiate from that side to that side, you have to end up with exactly what you have here. That's why you must allow for the constant. The integral of the sine of 2x plus 5, the constant here is 2. That's why I have minus a half. Of course, if we want to end up with a plus on this side when we differentiate from that side to that side, you have to have negative. Now here are some limits, and the integral from 0 to pi on 2 of cos x dx, that's the answer on that side. If we substitute pi on 2, we get sine of pi on 2 minus sine of 0, which is 1 minus 0, and that's 1. In a similar fashion here, if we integrate the left-hand side, that's the answer. Here are the limits. When you substitute them in, you get that line there. Now we know that cos of pi is negative 1, and we know that the cos of 0 is 1. So when you simplify from that line to that line, you get a quarter plus a quarter, which is a half. When you integrate that side there, you get that as the answer. When we substitute the limits in, tan pi over 4 minus tan 0 is 1 minus 0, which is 1. Here's a quick quiz to help you. Please check through the video at any time. The answer to the puzzle. What is the meaning of the following? A little on the large side. How cute is that? And here are the answers to the quick quiz, and the video is at your disposal.